In today's video, we will see what a cumulative frequency graph is, how to draw a cumulative frequency graph, and how to interpret or read a cumulative frequency graph and answer questions from that. So if we look at this, it's a typical paper 4 question in IGCSE divided into several subdivisions. So it says 120 students take a math examination. So the number is always the frequency. So remember that. We have the time. So that is the data being analyzed here in class interval and the frequency for each class interval given. An estimate of the mean time is asked. So for grouped data, mean is sigma fx. That is product of the frequency into the observation, the summation by the summation of the frequency. Since it's a class interval here, we need to take the midpoint, which represents just one value representing the entire interval. So the summation of f here would obviously be 120. It should be 120. 72 plus 21, 93. 9 plus 11, 20. 93 plus 20, 113 plus 7, 120. Now we have to multiply f into x. So typically 72 into 0.5 plus 21 into 1.5 plus 9 into 2.5 plus 11 into 3.5 plus 5 into 4.5 plus 2 into 5.5. This gives us the numerator sigma fx. I'm putting it in the calculator. Let us see what that is. So 36. 72 into 0.5 is a 36 and 21 into 1.5, 31.5, 2.5 into 9, 22.5, 11 into 3.5, 38.5, 4.5 into 5, so 22.5 again. 5.5 into 2 we know is 11. So 3, 8, 11, 13, 14 plus 6, 20. 3 plus 2, 5, 8, 10, 13, 15, 16. 0.5 into 4, 2. So 162 is what we are getting. So this is a 162 and the denominator is a 120. So 162 divided by 120 gives us 1.35 for a mean. If you observe, the time interval is from 0 to 6. So midway somewhere is 3, but 0 to 1, 1 to 2, 5 to 6, the frequency is distributed. So 1.35, although is not exactly the middle, it is in between all of these and it makes sense for us to have such a value for a mean. So answer to A part is 1.35. Maybe let me write it with a different color here. 1.35. Now part B. Using the table in part A, complete. Cumulative means from the beginning till the current. So m less than 1, 72. The first reading of frequency and cumulative frequency will always be the same. The second one says instead of 1 less than m less than equal to 2, it says m less than equal to 2, which means you should include 1 as well as 2. 72 plus 21, 93. This should be 93 plus 3rd or 1 plus 2 plus 3. Both are same. 93 plus 9, 102. 102 plus 11, 113. 113 plus 5, 118. 118 plus 2, 120. The last value of the cumulative frequency should be the same as the given frequency in question. This is definitely a must, and this is one way you can quickly check in between the sum if you're going on the right track. So, next comes actually the graph, that is part 2, and the question that follows I've put it here. Now let us plot the cumulative frequency graph. So to plot again we need a single value. For calculating the mean we took the midpoint, but to plot we always take the upper interval. So the plot is upper limit in the interval for the x comma the cumulative frequency. Why cumulative frequency is, if you look at it, the frequency goes up, down, it will change. So it's going to be zigzag if we try to plot. But a cumulative frequency graph is supposed to look like this. So if you get such a shape, this is clearly increasing. Only a cumulative frequency will give you an increasing graph like this. So 1, 72. 2, 93. 3, 102. So we use this table for the graph, the cumulative frequency always. 4, 113. 5, 118. 6, 120. Now we have frequency on the y. Every box is 10, 10. There are 5 small divisions, the minor grid line. So every small box or grid is 2. So 1, 72 will be one line above 70. 2, 93. So 93, this will be 92, 94, or somewhere in between first and second. Then 3, 102, which is just one value above 100. 4, 113, again in between first and second. 5, 118, just one below the last. 6, 120 is the peak. Cumulative frequency graph always starts from 0. So from 0, try to join these points. So it should have gone here. Okay, so with the pencil, sharp pencil, try to draw a smooth curve resembling this shape. It will seem to flatten at the end because the distinction between 118 and 120 is not very pronounced here. So towards the end the shape will flatten out like this. So this is done. From the graph, let us see how we can decipher the median, interquartile range and the 35th percentile. If you look at it, median is middle value, correct? Median is similar to Q2. If you see Q1, Q2, Q3, Q4, these are interquartile ranges. If you take the entire graph, Q2 is halfway, midpoint, median. Q1 would be the lower quartile, which is between the 0 and the median. And Q3 would be the midpoint between the median and the upper quartile. So they correspond to 25% and 75 percentiles. Now, how we do it from the graph is the frequency or the total is 120 here. 120 by 2 is 60. So 60 is the frequency that corresponding to the median value. 60 is here. From 60, with the sharp pencil and ruler, draw lines, horizontal line, till it touches our graph. The point where it touches your graph, drop vertical line. Again, with a ruler and a sharp pencil. Here, if you see, it is 2 blocks before 1. 10 blocks are 1. So every block is 0.1. So clearly this corresponds to 0.8. So the median should be 0.8 minutes. So we clearly see that the median and the mean are varying quite distinctly. So it depends on the scenario and the data for us to decide whether we have to choose mean, median or mode. Interquartile range or IQR is the difference between the upper quartile and the lower quartile. Like I said, the lower quartile corresponds to 25 percentile. Using another color. 60 is midway. Half of that is 30. From this, draw a line till it touches our curve. The point where it hits, drop a vertical line here. So this is 1, 2, 3 before this, which is 0.5. So the LQ is 0.5. From 60 to 120, 90 is the 75 percentile mark. At this point, drop it here. So this again is 2 blocks before 2. So 1.8. So lower quartile is 0.5, upper quartile 1.8. The formula I told you is 1.8 minus 0.5, 1.3 minutes. It's the interquartile range. 35th percentile. How would you calculate this? 35th percentile is percentage we do, right? Like that, percentile means in reference or comparison to the highest value, not 100% always. Here the highest or the maximum value is 120. So 35th percentile will be 35 by 100 into 120. For us to figure out which frequency is 35th percentile, we are doing this. Clearly, 2s are 10, 6 2s are 12, 7, 7, 6 are 42. So the frequency that corresponds to the 35th percentile is 42. Let us locate 42 here. 42 is one value above. Here again at the place where it hits, drop the line. So if you see, it is just 1 before 0.8 should be 0.7. So we were able to get the median IQR by calculating the lower quartile and upper quartile from a cumulative frequency graph, and finally any percentile that is asked. So I hope that was useful. I will see you all in another video. Thank you.